Hello everyone, my name is Alden. This is the blank script, and I'm sorry to say this is my final explainer video for my physics course. I'm so sorry, but I'm also not. This is probably going to be the most difficult one, and by probably, it definitely was because I've already finished it. And I know I didn't get the right answer. This has to do with workforce, and that is like the one thing I don't understand in physics. However, a good student like myself will continue to go at breakneck speed even if it's wrong, because this is a chance for us to learn. A chance for us to learn the right way on how to do something. Plus, I guarantee you it's going to be way more entertaining than me just shouting facts at you and telling you it's correct. Now that that's out of the way, let's start off with a little bit of an introduction. So first, I need to find all of the forces in this problem. Then I need to identify the work force, and from there I need to identify the velocity. So I already have all of the forces identified on it. As you can see, I got a gravity, I've got a kinetic friction, I have the spring force because the spring is being compressed. It's not compressed at first, but it becomes compressed. And finally, I have a normal force because it has contact with the ground and has gravity. Therefore, there's a normal force. All right, so we have our forces. Now we need the work that the object is doing. To find the work, we need to realize that, what is work? Work is the force multiplied by the distance the object travels. So I use that equation to write down all of the work equations on their own. It's after that I'm not quite sure what to do. Now, the thing I did was I wrote down which of these is changing and which of these are not changing between time 1 or time 0 and time 1. Because we know what time 0 is, we don't really know what time 1 is or how much time passes. I know that the kinetic force, it doesn't change. I know that the weight of it doesn't change, therefore the normal force doesn't change. The only thing that changes is the force of the spring. So that is what I used to get the velocity. I transformed this work equation into a kinetic energy formula, and I set them equal to each other. And what I tried to do was say that the initial distance, the distance of time 0, is different from the distance of time 1, which it would have to be. Therefore, you get the kinetic, and I use that to attempt to find the height, therefore giving me potential energy as well as a kinetic energy. I then use the conservation of energy theorem to say this energy has to equal this energy, because the energy you put in is the energy you get out. And I use that. I did some basic algebra in order to get them equal to it, or in order to get the velocity at time 1. However, I am not confident that this is the correct thing to do. Therefore, I cannot say for 100% certainty that it is correct. So, I would like you to tell me what I've done wrong and how I can fix it, because I'm genuinely curious now. I've looked at Khan Academy, I've looked at sciencing.org, which I have found I don't like that website, and a couple others that I didn't write the names of down. I didn't write the names of any of these down. I should have done that. And to end things off, my tip for you is to always have someone to check your work, because otherwise you'll end up like me and have no idea if your math or your understanding of physics is even close to correct. Having that secondary input is a necessity. But regardless of that, that's the end of the video. Those are the equations I used. That is how I found the answers that I did. And I hope you enjoyed this video. Like if you liked, dislike if you disliked. Don't worry about subscribing. I haven't done anything of note yet. I hope I will someday, but that day is not today. And I will see you later if you choose to come back. Bye!